Hi students, the topic for today is Cramer Rule and inverse method. You already learned about inverse method and now we are going to discuss the Cramer Rule. Cramer Rule and inverse method basically used for the same type of questions, means in which we have to find the matrix of variables. If there is a matrix in which you have variable numbers like x, y, z or x1, x2, x3, and we need to find out that, so we can find it by using inverse method or by Cramer rule. But what is the difference and what is the benefit of using Cramer rule? Why we cannot use the inverse rule all the time? Inverse method can be used for any type of matrix, but there will be some difficulty in finding the inverse if you have a 3 by 3 matrix or 4 by 4 matrix. Of course, we can find the inverse, but that's a long method which is not included in your syllabus right now. That's why for only 2 by 2 matrix, I will suggest you to take the inverse method. So if you have 2 by 2 matrix, you can go to the inverse method, which is easy to find the inverse and adjoint. And if you have 3 by 3 matrix, you can simply go to the Cramer rule because it will be easier than inverse method for 3 by 3 matrix. Let's discuss what is the Cramer rule and how we use this to find the unknown variable matrix. If you have given a matrix form, then it's very easy to identify what is the matrix A, what is B, and what is X matrix. But if the equation, this type of system of equations are given, so to solve the system of linear equation, we can also use the matrix. But the method that we will use will be the Cramer rule. So first thing, we need to make the matrix. There are three questions and I will solve one of these. Let's solve the second part and the rest you can solve it by your own. They are very easy. First thing is we have to make the matrix by using these three equations. So how to make the matrix? We make three matrix. One matrix is A, second matrix we make X, and the third matrix we make is B, which will be on the other side of equal. So A matrix will be the matrix of all the coefficients of these variable. You can see there are three equations and three variable. So the matrix will be of 3 by 3 matrix. Now let's write the coefficient of all the equations. So first column will be 2, 4, 3. Second column -1, 2, -4. Third column is 1, 3, -1. This is the matrix A. Now we will make a matrix X, and as we know there are only three variables x1, x2, x3, which is repeating in all the equations. So it means only three variable. We make a column matrix for the variable x1, x2 and x3, and equal on the other side B will make a matrix which will be the matrix of the values which is on the other side of equations. The values are 5, 8 and 3. This is also a column matrix. So this is how we can write the equation, linear equation in the form of matrix. Now the thing is we need to identify this X matrix. We called it as X matrix. First matrix we will call it as A and the last matrix we will call it as B. As we need to find X, there are two methods we can use here. One is we can use the Cramer rule, which we are going to find now. Other is we can do inverse method. But if we do the inverse method, for this we have to take the A on the other side, which will become the inverse. But as we are going to solve by Cramer rule, and I suggest you to solve 3 by 3 matrix by using Cramer rule, which is easier than inverse method for 3 by 3 matrix. So to use the Cramer rule, we will not take A on the other side. Instead of that, we will find A1, A2 and A3. Why A1, A2 and A3? Because these help us to find x1, x2 and x3. So the matrix A is this one. By using this A, we make A1 and find its determinant. First thing, we find the determinant of A. So the determinant of A, let's find it first, which is the first thing because this determinant of A will be used for all three x1, x2 and x3. So A determinant will be 2, negative 1, 1, 4, 2, 3, 3, minus 4, minus 1. Okay, let's find the determinant. The determinant of A can be found it. First we take this value 2, fix it and fix this row and column. Multiply the remaining values by cross multiplying. 2 times minus 1 is minus 2 and minus sign between them, and 3 times minus 4 is minus 12. Now the second value is with the negative sign. It's minus 1 because the first value is positive, second value with negative. It has already negative, so it becomes positive. And now leave this column, leave this row and multiply the other values. 4 times minus 1 is minus 4. Minus 3 times 3 is 9. First value positive, second value negative, and third value again positive. So other value, this value is positive, so positive is remains positive. Now leave this column, leave this row and multiply the rest values. 4 times 4 minus 16. 3 times 2 is minus 6. Now solve this, so it will becomes 2 times minus 2 plus 12. Minus 2 plus 12 will be 10 plus 1 minus 4 minus 9 minus 13 plus 1 minus 16 and minus 6 minus 22. After solving all of these, we will have minus 15, which is a determinant. So first thing, you need to find a determinant, which we did. Now how to find x? Because our concern is to find x. And what is x? X has three variables, x1, x2 and x3. How to find these x1, x2 and x3? So x1 is equals to capital X1 over capital A determinant. Determinant of x1 and determinant of A. X2 is A2 determinant over A determinant. And x3 is A3 determinant over A determinant. So main thing is, what is this capital A1, A2, A3? So these are actually again the matrix that we will make by using this A matrix. We will find these x1, x2, x3 later on. First find what is A1, A2 and A3. So A1 can be made by just replace this column with the first column. It will give you A1. If you replace this B column, sorry, B matrix with the second column, that will give you A2. And if you replace this B matrix with the third column, that will give you A3. So the first column A1, replace it with the first one, 5, 8, 3. Just replace it and all other will remain same. Minus 1, 2, minus 4, 1, 3, minus 1. This is A1. So we need to find the determinant of A1. Same, we need to find the determinant of A2. So A2 is, replace this B matrix with the second column. It becomes 2, 4, 3 and replace with the second column 5, 8, 3 and other same 1, 3, minus 1. Similarly, A3 can be made by replacing this with the third one. So first two remain same, 2, 4, 3, minus 1, 2, negative 4 and the third is 5, 8, 3. Now it's time to find the determinant of all three to put in this formula. So fix the first one, multiply these, 2 times minus 2 and minus 3 times 4 is minus 12, so it becomes plus 12. Now the minus 1, so minus become plus, 8 times minus 1 is minus 8. 3 times 3 is 9. Minus 9. And the third one plus 1 with 8. This leave this column and row. So 8 times 4 is minus 32 minus 6. Now simplify this. After solving this, we can have negative 5, which is determinant of A1. Now it's time to find determinant of A2. Fix 2 first and cross multiply. 8 times minus 1 minus 8. 3 times 3 is 9 minus 9. Now the second column plus with negative sign minus 4. 3 times 3 9. And the third one now with the plus 1, and 8 4 times 3 is 12. 8 3 is 24. Now to simplify this, after simplification it will give us 19. Same, we can find the determinant of A3. Fix the first one and multiply these 6 plus 32 plus 1 12 minus 24 and plus 5 minus 16 minus 6. After simplification it gave us 46. Now it's time to find the value of x1, x2 and x3. We will only plug the value of a1 or a. So a1 is 5 minus 5 and a determinant which is fixed for every minus 15, which will be after simplification 1 by 3. Second is 19 over minus 15. That's the answer. And the third one is minus 46 over minus 15, which is 46 by 15. So these are the values of the variable x1, x2 and x3 which we need to determine. Similarly, we can solve the first part and the third part. You can try it by your own. They are easy, same. You can solve it with the same method, same steps, just the values are different, so it is good for your practice. Here are again system of linear equation, but you can see there are two linear equations. So now it's up to you. You can use Cramer rule or inverse method. In this question, they just said solve the following system of linear equations. So you can use the matrix, but there is no restriction that use the Cramer rule or inverse method. So it's up to you. If we can write this equation in the form of matrix, so first thing is you should know how to write in the form of matrix, and then you will identify that which method you will prefer. So in each of the equation you can see only two variables are given and only two equations. It means the matrix will be 2 by 2, and the 2 by 2 matrix is easy to find the inverse. So first let's write the equation in the form of matrix. So the A matrix will becomes 2, negative 3, 5, 1. X matrix will be x1, x2, and the B matrix is 5 and 4. If we write in the form of AXB, so it will be AX equal B. Now, if you take A on the other side, it will becomes the inverse. And keep in mind, inverse will go on the other side and remains on the same position. Like if it is before x, so after going on to the other side it will remains before b. So A inverse B. This is very important thing that students usually do mistakes here, that they can take A on the other side and can write anywhere. That's a different, because multiplication of matrix can be vary by just changing their positions. So if we take on the other side, it means we can use the inverse method, and inverse method says that A inverse can be found by adjoint of A and over A determinant. So A determinant, you still need to find the A determinant, but on the numerator you need to do adjoint of A, and after finding A inverse just plug in this equation and multiply it with the B matrix. This is the one method. Another method, if you want to use the Cramer rule, then you can use the same way. X1 will be A1 over A, and X2 will be A2 over A determinant. So let's find it by inverse method. So according to the inverse method, first let's check the A determinant. What is A determinant? A determinant can be found very easily because this is only 2 by 2 matrix. 2, -3, 5, 1, and 2 times 1 is 2, minus 5 times 3, -3 is minus 15, and simplify this, 2 plus 15 is 17. This is A determinant. What is adjoint of A? Adjoint of A can be found by just changing the position of diagonal matrix and change the sign of non-diagonal matrix. So diagonal matrix are 2 and 1. If we change its position, it becomes 1 2 instead of 2 1, and change the sign of non-diagonal matrix, which will be 3 and -5. This is adjoint of A. And after finding these two, A inverse is actually 1 by 17, because determinant on the because A determinant is on the denominator, so 1 over 17 with adjoint of A, 1 minus 5, 3 and 2. A determinant is here, so let's find what is X, because our task is to find the variable, and variable is actually the X matrix. So the X matrix can be found by A inverse times B. So putting this A inverse value in equation 1, X is A inverse B. So A inverse is 1 over 17, 1, -5, 3, 2, and the B matrix, which is 5 and 4. Now it's time to multiply them to find the X matrix. So you know how to multiply row with column. So 1, this first row with the first column. So 1 times 5 is 5, plus 3 times 4 is 12. Now there it has only one column, so next move to the next row. So second row with the same column, but it will write in the next row. So 5 times 5 is minus 25 plus 8, and 1 over 17 is outside, and it becomes 1 by 17, and 5 plus 12 is 17, and minus 25 plus 8 is again -17. And as you know, 1 over 17 is divide with matrix. It means it will divide with every term. So X would become, when 17 divide with the first term, it give you 1. And when 17 divide with the second term, it give you -1. So X matrix is 1 and -1, which shows that X1 is 1 and X2 is -1. These are the values of unknown variable which we need to find. And for the same question, you can also use the Cramer rule and you will get the same values. Method will not affect the answer. Any of the method you use, it will give you the same answer. So you can also use the Cramer rule. For the Cramer rule, you don't need to take the inverse, but you need to find the determinants. You need to find three determinants: determinant of A1, determinant of A2, and determinant of A. And after finding all three determinants, you can find X1, which will be A1 over A determinants, and X2, which will be A2 over A determinants. If you want to use the Cramer rule for this question as well, so you can use the Cramer rule for this question. You can try it by your own. Similarly, you can solve rest of the question by using the same method. It's up to you if you use inverse method or Cramer rule. You can use any of the one. In the third part, you can see there is no x1 and x2. There is x and y. So just the symbol change. Instead of x1 and x2, you will consider it as x and y. And instead of a1 and a2, you can consider as ax or ay. Just this difference of symbol. nothing changed. Method to solve is the same. There are some different type of matrix. In this you can see again you have three system of linear equation, but in some of the equation you can see the two variables. That does not mean it have two variable. The total variables are three, but in some equations one of the variable is missing. So again it becomes the 3 by 3 matrix. So I will suggest you to use the Cramer rule. I will make the matrix form and you can solve it with the same method as we already discussed before. Let's first make the matrix form for the third part. In the third part, the coefficient of the first row, x coefficient is 1, y coefficient is 1, and there is no z coefficient. So it will be 1, 1, and 0. For the second row, the x coefficient is 2, and x is missing, y is missing, so 0, and the z coefficient -1. Same for the third row, it will be 0, 2, and -3. And the matrix form x, y, and z for variable. And on the other side, the B matrix will be 2, 1, and -1. And now you can easily solve this matrix using the Cramer rule by the previous method as we discussed. Similarly, for question number 1, the matrix form will be the coefficient 1, -2, 1, 3, 1, and -2. And in the third one, x is missing, so 0, 1, and -1. This is the matrix A, and the matrix x, y, and z is actually the x matrix, and the B matrix is -1, 4, and 1. Similarly, you can write the matrix form of second part, and you can solve it by using Cramer rule. You can try it by your own. I hope you understand the Cramer rule and the inverse method. If you find difficulty, so we can discuss it later. Thank you so much.